Hi everyone. Today we will discuss conjoint analysis. That is the most popular analysis nowadays in the market, and people, number of the industry and firms, they are using this conjoint analysis to get to know what products, those features they are offering, they are acceptable by the customers at what price, what could be the good combination they would like to know. So conjoint analysis is basically a multivariate technique. So this technique captures exact level of utility. Utility means we are talking about satisfaction. What satisfaction this combination will give to our individual customer highest, and what combination will give to the lowest, right? So definitely a person, utility means whatever amount we are spending, whatever the price we are paying, so we want to get maximum satisfaction. Right. So all the industries, all the firms, they are taking help of this conjoint analysis, and basically in this analysis we are converting ordinal ranking into the interval scale. Interval scale means utility that can be measures, and this is the ordinal ranking means we are giving them ranking. Okay, fine, this combination giving me best preference, I mean this one, this is the best preferred combination, it will give me, it will, I will put it on the first rank, and it's like, and then on the second rank, then on the third rank, so on, right? So after obtaining the best combinations of the product attributes, it gives highest utility the second and the third, and so on. In that way we are doing ranking of the products on the basis of their features. So conjoint analysis, there are two methods through which we can run this conjoint analysis. Number one is directly using the conjoint program in SPSS software. And here is second one is the through coding the variables in the form of convert the problem into an equivalent regression statement, right? So today in this video, what I'm doing, I am covering only the first part directly using the conjoint program in SPSS program, SPSS software, rather than through this one is the regression statements. So I'm not doing this regression statement today, and definitely I will do it in the next video. This video is I am covering only this SPSS software conjoint analysis, right? For this to run this conjoint analysis in SPSS software, I would have simultaneously, I will use three files at a time. One is attribute of the products, where I have defined all the features, all the products attributes. Second is responses by the customers. When the customer is giving ranking of these features, that is my second file. Again, that would be in the SPSS. And third file by the SPSS syntax file. And syntax file we are using to write coding, right? How we have to run this conjoint analysis. So one by one, we will start. I have taken today one example, a very good example that is a very important in decision making of the how the customer is going to take decision making, what they want actually. See, sometimes what happened, this one is the conjoint analysis. It can be possible, but best combination, it can be possible. But what happened, it cannot be feasible to the industry. It can be possible. So, because obviously we are human beings, we want maximum, we would have maximum satisfaction when we are getting in minimum price, we are getting maximum features. Let's say we want to spend only 40,000 to purchase a laptop, but we want speed is also should be very good, as well as size is also very good, as well as processor should be very fast, each and everything we want, but at the lesser price. So that will give us maximum satisfaction. But it would not be feasible to the company because it's not possible. I mean, because that would not be costing to the company. So it's not feasible. So we are taking example of laptop attributes plays important role in the decision making. It might be possible customer will choose extraordinary features at very low price, but actually it's not feasible. So now conjoint analysis will be helpful. So for this purpose, I'm going to take one of the important feature in SPSS. It's available, orthogonal design. That means out of these combinations, system will identify on random basis few cases which give good representation of all the attributes. Those are the features we have. Right, so we have to apply this orthogonal design, and as well as here is, you could see here, I have taken, first let me explain you in the Excel sheet what features I'm going to take at the time of purchase of laptop. Number one is the price. Price is very, very important. Second thing, important feature is processor. Third is dimensions, means size, and RAM. RAM means at a time how we have to run number of the programs. So that would be RAM. Price is I have taken in 1,000, 40 to 50,000, right? And three category I have taken: 40 to 50,000, 50 to 70,000, 70 to 1 lakh. 1,000. I mean, this one is the 1 lakh. 100,000 means 1 lakh. Processor I have taken i3, i5, and i7, right? And dimensions 14 inches, 15.6 inches, 13 inches. And RAM I have taken 4, 8, and 16. Obviously, if suppose if somebody will say, what gives you maximum satisfaction, so definitely I will choose this 40 to 50 is the price, and processor should be very good because the speed would be fast and less time consuming. And dimensions, it's up to you how you have to carry, but I would, because customer would prefer 14 inches, but definitely I would prefer, if I would take it to that would, I will take it 13 inches. Is a handy laptop, lightweight laptop, and I can carry anywhere, and I can use as a tab also. RAM is 1486, obviously I want it, but it can be possible to the firm or to the industry, those are giving, offering this product to the customers. Is it feasible combination? Might not be. It's not a feasible combination, right? So here is, you could see here how many combinations are here, right? We will, because if suppose we are taking all these four attributes, four parameters, so you could see here how many combinations are here. Combinations are, here is 3 parameters in price, so 3, right? 3 multiplied, right? Ultimately 3 parameters in processor, right? 3 parameters in processor, so again 3, and multiplied, right? And then again 3 in dimension, right? 3 in dimension, and again we will multiply, right? Again there's the 3 parameters are in RAM. So total combinations are, how many combinations are here? Total combinations are, we can talk about 81. 81. 81 combinations means 81 cards. 81 cards means you are giving to the customer to rank all these 81 cards. Which one is your first preference? Which one is your second preference? Which one is your third preference? I mean total 81 preference from one customer. It is not feasible. It is not feasible. Customer would also get confused. If suppose I would added one more feature also here, so that would again multiplied by 3 also, right? So that would be a bigger size that is not visible to a customer. He or she can be ranked. So what we have to do in this situation, we have taken, let me take, I will taking one new spss file, data. Here is data, and you could see here there is the one option, orthogonal design. Orthogonal design, you could see here there are two options, generate display. So I will click on generate. You could see here factoring. So my first factor is price, as I have shown you in my Excel sheet, price, right? So we can say here is the level we can give price of laptop, because I am taking laptop as a product, laptop. I will add it, and now I will click on this. You could see here. You could see here what you have to do. Right, we will remove it first. Right, again I'm doing the same process. Price level is, I'm giving price of laptop. A moment I will add on. You could see all these are not functional, these tabs. Moment I will add it, add, and I will click on this. You can see define values is functional. Now I will click on define values. So there is, you could see here in price, how many categories I had given? 3. So I will define in this file all 3 categories. Number one is, number one, level is 40 to 50,000, 50K. Second is I had given, I think, 50 to 70K, 70,000. And third category, I have taken 70 to 100,000, right? So I will continue. Then the next factor, what I have taken? Next factor, I have taken processor. Next factor, I have taken processor. So processor is, next factor is, I will say processor. Processor means here is, you can say processor of kiska, I mean there will be laptop. Then I will add it, and again I will click on this define values. Again you could see here I have taken 3 categories in processor. So now again we will define processor. Number one is, you could see here, number one is i3. Number two is, you could see here, i5. Number 3 is 3 kinds of processor. I have choice, right, i7. Continue. Right. Now we will define third factor. And what is our third factor? Third factor is dimension, right? So again, I have to take dimension. Here is dimension. Dimension means we can talk about the size of the laptop, correct? And we will add on, and you could see here a moment I will click on define values. 3 sizes I have taken. First is 14 inches. No, sorry. First is value. Number one, we are giving number one. Here is 14 inches. Number two, I am giving 15.6, and number 3 I had given 13 inches. And now continue. 3 sizes also available. And fourth, last one is the RAM. 4, 8, and 16. They are the 3 categories. So I would mention here is RAM, and RAM means here is the RAM of laptop. RAM of laptop. Correct. Then we will add on. Again, I will click on this. Define values. Number one, I said 4. Number 2, I said 8. And number 3, I would mention is 16. So this is the continue, right? Now we will continue, right? And data set name we have to define here. What we have to give? We can say features, right? We can say features, or whatever is the, we can say features. I mean this data set name I had defined here, right? And not create new file, and reset random numbers seats to yahan par, I mean you could see here option is the, here is I will give, let's say 1 lakh, right? And option is hold out values, let's say I'm giving 7. So number of the, sorry, minimum number of the cases to generate, sorry, here is a minimum number of cases to generate. We can give around 27, right? And here's the number of the holdouts I have to give, let's say 5. And then we will, and randomly mix all the cases. Continue. Moment I will continue, I will press OK. Right. So you can see here a plan is successfully generated with how many cards? 27 cards. How many cards? 27 cards. 27 cards means 27 combinations. Up now it is visible. You would see here. Now it is visible. Now it can be possible Now it can be possible that we can show these 27 cards to our customer, to our respondent, and I would ask them, please do ranking of all these cards. It can be possible. So this message you will get it, right? So now I have shown you how you have to work on this file. So I'm just closing this file, right? No, I don't want to save this, and as well as I'm closing this file also, because I already have my previously filled this data. And you could see a data view would be like this. What we have defined here: price, processor, dimension, RAM, status, and card. Yes, these two things are add-on. A moment we will continue, then you could see here. This one is the price, processor, dimension, RAM. That is already defined. And you could see here, where is the design, hold out. And you could see here, just a moment, these are the numbers. These are the number, right? Price we had defined here 1, 2, 3, right? And same is processor 1, 2, 3. We have defined all the three sub parameters 1, 2, 3, and RAM is also 1, 2, and somewhere is the 3. Status 0, 1, 0, 1. 0, 1 means what? I will show you. Here is the, that means that is the feedback. Holdout means we have taken 7 holdout just to run this process, to run this test. And cards means this is the ranking of the cards. You could see here how many cards are generated. There are total 39 cards. 39 cards means you could say 32 cards has been generated, and rest of these 7 are holdouts. You could see 7 holdouts I had mentioned here. 1, 2, 3, 4, 5, and here is the 6, 7. So total 7. So 32 and plus 7 is 39. So that is why total number of the rows are 37. Correct. So till here, I'm sure it is clear. Now what we have to do, now we will open up our customer rank. I have already taken, to save my time. Here is data view. You could see here. In this file, what will happen? You could see here, total how many ranks we have defined. There are 39 ranks. So you could see here, I have taken total 39 rows. Total 39, 38 rank. You could see here 39 ranks are here. Total respondents I have taken 25 only. 25 respondents. I have shown them all these 39 cards. Those I have taken in my example. I mean, that I have shown you 25 cards generated. There is the 32 cards already generated. So I will show them, and please, I had asked them, please rank all these things, right? Rank these cards. So total you could see here, here is the 39 ranks are here. Correct. Now, how we have to run conjoint analysis on this response? So what we have to do, you will go there, you will open up this file, and here is open a syntax file. Syntax file would be, here is the, sorry, new file, new syntax file. And syntax file would be like this. Syntax file will be like this. So what we have to do, you will write a syntax over here, right? How you would write a syntax over here? I have already prepared a syntax file. You could see here. This is my syntax file. Here in this syntax file, you are going to define conjoint plan. First is conjoint plan. Conjoint plan, like suppose you are writing, I will again open up one more file, then you could see here how it will react. Here is, right? Let's say I'm writing conjoint. You could see, moment I had write C, right? Conjoint. So you could see here, that is in the drop down box is already available. So you will click on this, right? So that would be become red. And then you will write plan, PL, and you could see here in the drop down box, you will pick up plan, right? Then you will say equal, right? Equal, right? So in the same way, I did my syntax file, I had prepared my syntax, and this is my path. This is my path. Where is my file is put it here in the C drive. You will define, simply you will go there where you had put it that file. First file I had opened up attribute file. Attribute file, you understand? Again, I'm showing you attribute file. This is my attribute file where I have defined price, processor, dimension, orthogonal, you remember? So I had defined all those things. So this is my attribute file. I had given this name as attribute file. So now you could see here, I have defined here this attribute file where it is put it in my C drive, users, Ashulekha, desktop. That file is it's placed at desktop, and UU March 15, June 30th, 2021. This is my folder name. And there is the, again in this, this is the folder. In this folder, there is the one more folder, SPSS practical, and then the conjoint analysis. There is the folder, and in this folder, this file is put it here. Correct? So you have to select a path. You have to go there on that file, and you have to go in properties, and you will select that path, and simply you have to define this path here. Now, next thing is data. Same thing is in data. I am taking my syntax file that I had already opened to you. No. Syntax file, right? So after defining this thing, you will come into the next row, and you will, here is, you will write data. A moment, right, you will write data, right? That would also be, you can select from drop down box, right? And here is, you could see here, this is my syntax file, data. Again, in this data means plan is this data where I put it data. Data is already customer rank. This is my data file. This is my data file where I have shown all 39 cards to my 25 respondents, and they had given ranking as per their choice. Let's say first respondent, right? First respondent, this is the serial number, this is the respondent serial number. First respondent had given rank 1 to first combination, right? First card that already generated. Second, 15, this person had rank 15 number card, then rank 3, 22nd number card, then rank 4, and so on, right? So this syntax file here is sequence. Here is, after this data, you have defined this file path. Then sequence. Sequence means what sequence? Sequence means ranks are 1 to 13, because in my case, total how many sequence has been generated? Total number of these sequence generated 1 to rank 39. I have defined subject. Subject is my serial number. Subject means respondent number. Serial number means my respondent number. And then factors, how many factors I have taken? Again, backslash factors, price. Price, why I have defined as linear less? Linear less means simply we are talking about linear less means price should be less, then people are getting maximum satisfaction, rather than I would say linear high. So if the price is less, people are getting maximum. It would be fine. Processor, linear more. Linear more processor, processor should be on the higher side. i7, then further i3 is the lowest one, then i5, then i7. So people, they always have, when the processor is on the higher side, they will get the maximum satisfaction. Then the dimension is discrete. Discrete means there is no impact on this dimension. Sometimes it depends upon the people whether they would prefer 15 inches, they would prefer 14 inches, 13 inches. It depends upon it. So dimension, I said discrete. There is no thumb rule. People, they would prefer only 13 inches, that is on the higher side or lesser side. No. RAM, linear mode. Why I had defined RAM linear mode? Because RAM always on the higher side will give the maximum satisfaction, and I had opted this one is this option. I will tell you later on. Then we have to write print. Achha, now what would happen if suppose I will run this file, right? How you have to run this file? I will remove this. I'm putting up in my another syntax file that I had already opened to you and pasting here, right? Later on, I will take it from this place, and I'm removing this feature print summary only, right? And plot all. I will tell you later. First, let me run my, I will remove this and print summary only. Also, I have removed this. Right. What will happen? If I would, this one is the green sign, you could say, I will run this. I will press this green sign. Right. I will press this green sign. You could see here, there is, I will press the green sign. Right. Moment I will press this my green sign. This is the, where is the output? This is now. Output is coming. Now you could see here. Output is conjoint analysis, right? Price, number of levels, relation to ranks and all, linear less, processor 3, linear mode, dimensions discrete, and RAM is linear mode. That I have defined there, right? So simply what you have to do, you can paste it here in your output file. In your output file, here is, you can paste this, and you could see here, right? I mean, model description, all these three things are, we have already defined. Then further we will go to our output file. Then the next one is subject. Subject is, right, here is, you could see here, dimensions. We have taken 3 categories, right? 3 categories. Again, I will copy this thing at my Word document, and you could see here, there is the more I mean, better visibility. Dimension is 13 inches, 14 inches, 15 inches, and utility estimates are here. Standard error is here, right? So that means it shows, I mean, that is in the dimension category, you could see highest utility by this 13 inches, 4.167, but 14 inches, there's the, that shows not much, and 15 inches, that is again minus. Price 40 to 50, and 50 to 70, and 70 to 100. That is because this data I have on the, what data I had run this test, that is entirely hypothetical. That is not actual and genuine data. So these are these that might be possible when you have to collect this data, genuine data, right? So definitely genuine data in the sense ki, I mean, respondents, how they are giving the responses against this. So your, this one is the utility figures would be changed. 50 to 60, here is the 3, and 72 one is the this thing. And the processor, when we talk about i3, this is the minus 1.773, and i5 minus 3.543, i7, that is, it shows. And this one is the RAM is minus 2.8, and that means not much they are. That is the relationship in between the RAM and as well as this utility estimate, right? Where is the negative part is shown. Now we come to the next thing is the importance value. Dimension 42.128, right? Price 16.049, processor 18.96, and RAM is 22. So that means highest is for the dimension in my case, right? And this one is the A stands for reversal, right? 3 reversal are here. Reversal means those are not giving, those people are not giving as a highest. This one is the importance, and the price then is the least one. And the coefficient, you could see here, the price here is the beta coefficients are estimates 1.5, processor 1.773, and 2.136, and after that correlation is here. Correlation is not too good in my case, but in your case, correlation between observed and estimated preference is 0.459 and 0.312 and 0.33, right? So that is low. Up here is, you could see here, this one is the, in the case of subject 1 means first respondent only analysis. This one is the first respondent. In that way, same, this one is the first respondent analysis. This respondent prefer, I mean, dimension is giving at the highest point and price is lesser. But in the second respondent who had given this ranking, in his case, you could see here, here is 47 for dimension, price is 17 and 15. Processor is the least. But in that case, you could see here in the first respondent, that is the again this one, the price was least. So in that way, all 25 respondent data is here. You could see here third respondent 33, 11, 23, 31. This respondent had given dimension on the topmost and RAM on the second topmost, second highest. And in that way, respondent 4, right? Respondent 4, respondent 5. In that way, this thing is going on. Now, that is very difficult to, I will go one by one all the respondents output. So better what I will do, I was talking about this thing, I will, here is the, you can see here, I will write here, this one is the, I want plot also. So I said plot, right? You could see here plot, here is plot all, right? And here is also, I would say in the next line, right? I said is the same thing, print summary only. I want summary in a one summary sheet, right? All the respondent summary, I would like to say on a one sheet. Moment I would run this, right? So I have run, and you could see here, now the summary is here. This is the number of the reversal, and this is the summary sheet. Here is the same is here, utilities. You could see this is the for all the respondents, right? Utility estimates minus 1.30, 14 inches, 1.2 highest. This thing they had given this 1.272 for the 14 inches. And this is the summary. I mean, overall by the all the 25 respondents, and price is 0.404. 50 to 60.807, and highest is the 72 100. Processes is I3, I5, and I7. These are the utility estimates are here, and RAM, and this is the constant value. And importance value, you could see it, highest importance they had given to dimension, second highest processor, third highest price, and fourth highest is the last one is for the RAM. In my data, because might be possible data can be wrong, and data when you are collecting this data, that is the something else results would come out. And beta coefficients, you could say 0.404, and processor 0.387, RAM is 1.87. And this one is the values are correlation. Well, correlation is again very poor, 0.619 if there's the and but all are the significant correlation. And the number of reversal means RAM 16 people, they are not giving weightage to the RAM, and 15 people they are not given weightage to the price, they are reversal, and processor is also same. And now you could say all the 25 respondent data summary is here, right? Summary ko I would copy in my this thing, I will paste it here. You could see here, see, this one is the summary and number of the reversal. That means this person is accepting, this person is accepting. There's the somewhere is the zero reversal. That means this 17 number respondent, it had given all the points weightage, all the points ranking, right, in the positive direction, and in the 18 like only one reversal, correct? So, and as well as, yes, I would like to show you in my output file, plot all. You could see a summary in the form of the plot, right? These all are serial number means all are, I had already copied this data in my Word file. You could see here, this is the respondents. There is 1 to 15, 1 to 25, all the respondents are here, and you could see here, it is reflecting, right? How many people, I mean, this respondent is giving weightage to 13 inches, and this one is the for the 14 inches, and how this respondent is given weightage to this one is the this is giving the utility 6, right? Highest utility, one respondent, right? Through this 14 inches. In that way, number of the curves by the all the, you could see here, I'm just showing my output file. Yeah, in individual subject utilities, right? Individual subject utilities related to this one is the price. This is the price of the laptop, right? This is the speed of the laptop we have already defined, and this one is the storage of the laptop, right? And this one is the, these all are the factors are here. In that way, this summary utility you could see, and you could be, and industries can use this data, and after that they could be able to define what utility people are getting, right? Like suppose we will talk about, right, in this we would like to calculate their utilities, right? How much utility they are getting. Like, so here is the, let's say 14 inches. In this case, 14 inches is the, there is the maximum, right? So you would calculate these values, right? What is the number one respondent had given data, right? Number one respondent had given this data, serial number one, right? Number one rank, right? It has given to, it has given to, in this category, rank 1 to number 1, right? Here is the first card, and first card, what is this? These are the, my cards are here, right? First card 50 to 60 price, i3 processor, and dimension is 13 inches, RAM 4, and status is, I mean, that will be, I mean, this is the not hold out, this is the this person is accepting, and this one is the card one. To card one, this is the card one data. So simply what we have to do, these values we will convert into the utilities, and after that we will get to know which particular combination is giving maximum satisfaction, which particular portion is giving maximum satisfaction, right? So I hope this conjoint analysis is clear to everyone, and I'm sure you would utilize to conjoint analysis to know where is the when we are launching a new product, or companies are launching in a new product, which features are giving maximum satisfaction to a customer, and accordingly we can modify our product price, we can modify our product features, we can modify our products other attributes, right? So I'm sure that would be helpful, and definitely in the next video I am coming up with this through coding the variables in a form to convert the problems into equivalent regression statement. So I'm sure that is helpful to everyone. Thank you, everyone.